If you can dream it, you can build it. Dream of designing a device that will change our lives. Now imagine you can make it happen. Make it real. Make it fast and powerful. Make it intelligent and make it learn. Make it analyze and predict. Make it fun and creative. Make it look sharp and gorgeous. Make it friendly, user-friendly. Make it efficient and productive. Make it smart and connected. Make it prevalent and extensive. Make it secure and protected. Make it safer and autonomous. Make it sound clear and pure. Make it speak
and understand.
Make it free, truly wire-free. Make it sweat and stay in shape. Make it move and sense all around you. Make it grow and make it nourishing. Make it all happen with CEVA. CEVA licenses ultra-low power smart sensing and wireless connectivity solutions. CEVA's IP powers more than 10 billion devices worldwide. Dream it and make it with CEVA.
Sorry guys, I was on mute. So today we're going to talk about SensPro, which is CEVA's latest IP platform that's really geared towards contextually aware devices. If you look in the market today and really what's happening in society, technology is really becoming much more integrated into our lives. It's moving from utilizing devices and electronics that traditionally we use to inform us, to entertain us. And now we're kind of moving to devices that help us see, they help us feel, and help us really to react to the world around us. And really an important part of this shift of how we use electronics today and how we use devices is largely dependent upon sensors. So we're utilizing sensors today to be our eyes, to be our ears, and then soon the next step is to take those sensors and allow us to improve our decision-making ability with the aid of certain devices. These are used in some markets like automotive, home automation, audio, smart cities, robots. Within all of these markets, sensing is kind of this first step of creating contextually aware devices that will help us gather information, analyze the information, and react appropriately. So if you look at from a sensor side, devices that are utilizing sensors to gather this information are using many different types of sensors. This could be anything from visual data, so looking at cameras, time of flight sensors, structured light, there's LiDAR, there's radar. We're also utilizing motion data, so things like gyroscopes and magnetometers, IMUs, accelerometers. And then finally, our ears is we're utilizing audio data, so utilizing microphones. Analyzing this data requires a couple of different things. One, we need the ability to either process each of these sensors independently, or for really contextual awareness, we're using multiple sensors and fusing them together to get kind of a model of what's happening around us. In order to do this in the devices that we're using today and tomorrow, we're using many different types of ways to process this data. There's the ability to process data utilizing traditional methods like computer vision, or we're looking at kind of the next step of these devices and we're utilizing more artificial intelligence. So in order to really take to have the ability to process multiple sensors, multiple data types, different kinds of algorithms, you really need a new type of process architecture to fuse and process data efficiently for many different sensor types. And that's kind of what we're talking about today. And that's what SensPro is. a good example, an example where we've seen sensor fusion a lot these days is within automotive. So if you're looking within automotive at vehicles that are used to protect and save, save lives and to do different scenarios for active safety or even minimal use cases, there's a need for the use of multiple sensors. If you look at automotive in a typical vehicle that is used to basically avoid or do automatic emergency braking, we have anywhere upwards of 4 to 6 radars, maybe 4 greater cameras, 1 LiDAR. We're also looking at things like V2X or car-to-car communications. And then we have the ability to sense these different sensors into basically a contextually aware picture. So what these multiple sensors give us is the ability to improve accuracy, it improves the reliability, and also improves the safety. So if you think about automotive, we have to make sure that all the sensors are performing as they should. And one way to check the performance of this is to compare sensor data from multiple modalities to get a more accurate picture. Also, if you're looking within automotive, there really isn't a perfect sensor. Each sensor has its pros and cons. Where one sensor may perform well, during daylight hours, it may not perform as well at night, or maybe if it's foggy or if it's raining. And so really what we have to do is we have to combine these sensors to take advantages of the pros of each of the sensors to reduce limitations, improve reliability, improve performance. An example of this is automatic emergency braking. Automatic emergency braking is where the vehicle stops automatically, whether it's a pedestrian, a bicycle, or a car. And it needs to work at all times, in all hours, in all scenarios. And in order to achieve that, we really need to utilize sensor fusion and utilize multiple sensors. So in that particular, example, we're using. Sorry, I gotta go back here. Iris, can we go to the previous slide? Thank you. So really, in order to do this, we have to utilize multiple sensors and fuse them together to get an accurate picture. Another example, and this is probably more an advanced example when it comes to autonomous vehicles, is path planning. So what's the safest path that the vehicle can travel in order to pass cars or avoid obstacles? And this is requiring lots of different types of sensors that are being fused together. This is highly accurate GPS to determine where the vehicle is within the lane. It's utilizing things like camera for visual SLAM and object identification. We have motion detection for when maybe the GPS doesn't work to determine where the vehicle is. We have radar to determine where objects are around the vehicle immediately and also far away. We have LiDAR, which gives us a more detailed, accurate picture of really a 3D model of what's going around the vehicle. And then of course we have mapping. So doing something like path planning is requiring to really rely on multiple types of sensors. Within other markets, there's many other examples. So for example, robotic vacuums, we're utilizing vision or wheel ticks or motion or IMUs, AR, VR. I think we're going to talk a little bit about driver monitoring systems in Naveen's talk next, but that's another example in how we can utilize sensor fusion for creating contextually aware devices. So if you look at CEVA and where we focused primarily, our technology is focused around 2 large areas. One is wireless connectivity, that's anywhere from long range, so cellular baseband to 5G DSP-based platforms and cell phones, to more short range, which is IoT connectivity. So these are things like Bluetooth and Wi-Fi. Within the smart sensing area, we've traditionally focused on each of these types of sensors or technology areas individually. So particularly in automotive and other areas, we focused on camera. So creating vision DSPs, products for neural network acceleration. We're providing software products for things like neural network inferencing. We've made investments in acquisitions of companies who are working on IMUs, both software and hardware algorithms. We're working with microphones, so DSPs and software technologies for different sound technologies. And what with kind of the next step within CEVA and within the market in general is how do we basically combine these sensors to give us a more realistic picture of what's going on around us. We recently announced a product, SensLink, which is a software platform that has the ability to combine multiple sensors. And so this was kind of our first area moving towards this sensor fusion arena, along with the acquisition of Hillcrest Labs. And really what our next step into this is really to create a platform for both doing sensor fusion and also relying to do things like computer vision and neural network acceleration. And so this is what SensPro is, what I'm talking about today. And this is the industry's really first high-performance sensor hub DSP. So this is designed to serve processing and fusing data from multiple sensors. So these include things like camera, radar, LiDAR, time of flight. On the audio side, it's microphones, IMUs for motion, and to combine these sensors and to process these different kinds of data types to create contextually aware devices. So SensPro's architecture is highly configurable. It's self-contained. It doesn't need another processor to run. It has the ability to combine scalar and parallel processing, both for floating point and integer data types, and also can do deep learning and inference. SensPro also has the processing capability to expand what we've done. Predominantly, we worked on a lot of computer vision, but now we're expanding that to do things like sound, doing things like SLAM, so simultaneous localization and mapping workloads. We're utilizing a CEVA BX2 scalar processor for really good control code execution. And then of course, SensPro is initially offered in 3 cores and configurations, and I'll get to that later on in the presentation about how we can right size SensPro to fit your needs and your design. So SensPro is derived from previous technology, which was the CEVA XM6, which was a vector processor that's really utilizing and concentrating on computer vision. From moving from XM6 into the SensPro family, we've been able to carry on the same computer vision functionality as we had with XM6, but we're able to add additional performance and use cases. So we have a 20% increase in frequency running at 1.6 gigahertz, up to 8x performance and performance improvements. From a power efficiency standpoint, 30% energy savings, and through the utilization of things like CEVA BX2, we're also to do things like 30% code size savings. So these are things that we can do with SensPro. So SensPro is it's modular and scalable architecture. So I'm going to talk about the different configurations. It's very versatile. So it's the ability to process things like SLAM, radar, sound. In addition to that, we're still carrying on the legacy of doing computer vision and neural network inferencing. It's able to do either single or multi-sensor contextually aware devices. So whether that's a rear backup camera in the vehicle that's only utilizing one sensor, or it's looking at things like automatic emergency braking or surround view systems in which you are utilizing multiple sensor types. From an efficiency standpoint, industry-leading performance per watt across the board in both computer vision and other algorithms. Highly parallel processing, so it has the ability to switch contextually from different types of data types. It does have high performance single and half precision floating point. And then we're carrying on the legacy of our other devices, which has a mature neural network and computer vision software infrastructure and tools. So as I said before, SensPro is really an evolution of CEVA technologies. We've had tremendous success in the market, and we're basically taking some of the best parts of these architectures from our previous products and not combining them 1, 2, 3, but really taking the best parts of these architectures and combining them together into a single architecture. So we're looking at NeuPro. So NeuPro is, we utilize NeuPro and its AI processing capability. We're utilizing things like CEVA XM6 and some of the things from the architecture from XM6 for vision processing. And of course, we're creating good control code through the utilization of CEVA's BX2 scalar DSP. Within SensPro, we're also looking at what we've been able to do through some of our other families. So for example, flexibility of hardware configurations. Within NeuPro, we have the ability to right size your AI accelerator depending on what what's your application. So we're able to use customized area and power solutions. We have a balance between fixed and floating point operations. We have the ability to multitask with SensPro, so switching between AI or other sensor processing tasks. Then really multi-sensor support, so able to process different data types, whether those are 2D or 3D vision, audio, speech, and motion sensors. So I said before, just kind of looking at some of the latest features of SensPro. So as I said before, it's a self-contained specialized sensor device. It's highly configurable, and we're going to look at some of those things. It has state-of-the-art microarchitecture that combines scalar and vector processing units, and then also has parallel processing capability. So some of the SensPro feature highlights. SensPro is an 8-way VLIW highly configurable architecture. As I stated before, has a 1.6 gigahertz max frequency. So that's at 7 nanometers. It's utilizing a very capable scalar processing core, which is the CEVA BX2, which is really good for control code and seamless migration. The CEVA BX2 is scored 4.3 core mark per megahertz score. From a floating point capability, very highly capable. So 400 gigaflops of 64 single precision and 128 half precision floating point max. It does have the support for complex data and radar. From a memory architecture standpoint, we're looking at 400 gigabyte per second data bandwidth, utilizing 4-way instruction cache, 2-way vector data cache, and then we also have optimized DMA and queue and buffer managers for the memory subsystem architecture. Looking at the configurations of SensPro, we have three base configurations, which basically are combining different feature sets that are available with SensPro, whether that be floating point or the ability to scale based on the MAC configurations. If we look at the low end of SensPro, we look at the SensPro 250, which includes 256 8x8 max. These are used predominantly for lower use case scenarios for vision and audio, so applications such as surveillance, action cameras, smart home personal assistants, low-end ADAS in mobile applications as well. Within the SPF 500F, we're able to add floating point capability. This is done largely to both improve the ability to do computer vision and also add additional scenarios like SLAM. So these are things used for like drones, home robots, AR, VR handsets, and smart glasses. And then if you want to utilize SensPro for AI processing, we have a larger configuration which has 1,000 8x8 max to do AI processing. So if you look at SensPro, really is a self-contained sensor hub processor that's able to scale really in performance for a broad range of end markets and applications. One of the important features that we've added to SensPro is really CEVA has tried to differentiate itself in the market and lead competition with the support of binary neural networks. I'm going to talk about CDNN in a bit, and Naveen also will talk about CDNN but we really have a tool that's able to customize, quantize, and balance performance and accuracy of things like 8-bit or even binary neural networks. If you look at the market, really neural networks are becoming more powerful. So this is requiring more complex networks. As these networks become more complex, they're becoming larger, which requires higher computation. If we look at where these types of devices are being utilized, they're really edge devices. So these are maybe devices that are in an IoT system, that are small mobile devices. These devices are often battery powered and constrained by power. They're also constrained by the amount of resources that are able to put in these devices to process these neural networks. And because of these constraints, there's really a restriction to use these cutting edge neural networks. What we can do is we could utilize binary neural networks to reduce the computation, the power, and the size, and still be able to utilize some of the complexity and the advances of these more complex neural networks. From a performance standpoint, we are improving in size and efficiency and accuracy. And so we're really utilizing binary neural networks to be able to implement these higher level neural networks into smaller devices. Within SensPro, we are also providing a complementary, really a full solution and platform approach. So we have CEVA optimized software libraries. So these are things like ClearVox and CEVA WisPro, which we're able to utilize for sound processing. Ben today is going to talk about wide angle imaging and the work that we're doing with ImmerVision. We have CEVA CV. We have a SLAM SDK. Within neural networks and inferencing, we have CDNN, which I'll talk about in a second. And of course, we're supporting open frameworks like OpenVX and OpenCL. We can combine these optimized software libraries to create a variety of OEM application level software. This can be anywhere ranging from speech recognition to imaging, all the way through neural network and inference processing. So I spoke about CDNN prior, and what CDNN is a framework that it creates basically an offline tool that takes 32-bit optimized floating point networks and is able to utilize these neural networks and run them through an offline tool to quantize and optimize these neural networks for smaller devices, devices for IoT. So we're able to basically take this and create either 16-bit, 8-bit, and soon binary neural networks off the CDNN runtime for CDNN. So I think Naveen will get into this more, so I'll leave that to him. So if we really look at SensPro, the key takeaways within SensPro, really we have a modular architecture. So with the configurations, the SPF 250, the SPF 500, the SPF 500 and the SPF 1000, we have the right types of devices that can utilize different configurations to right size the device. SensPro is cost and energy efficient, so it has leading performance per area through efficient design. It's very dynamic in its processing, so this is able to do multiple sensor types and also do multitasking. Any processor sensing, so it can do anything from imaging, radar, all the way through LiDAR sensors, audio sensors, and then of course it has a full software tool chain. So these are things like CDNN compiler, which I spoke about and we'll speak about a little bit in the future, but also utilizing things like CEVA CV, OpenVX, and a variety of complementary software frameworks and libraries. So that is basically my discussion today about SensPro. I hope it was informative to you. So I will now hand it over for some Q&A.